So let's move on to a related topic called global and local, about the scoping of the variable, especially in the context of a function. When the function is defined, it is not being run. There's no such thing as uh, dynamically created namespace or scoping, not yet. But even when it is not run, we can tell whether a variable is going to be global or local, because inside a function like this, all right, all variables that are not defined as global will be local. So let me say again, inside a function such as this variable diff, it's not declared as global. So when we first initialize it with a calculation on the right hand side, which gives us a value to be assigned to this variable name called diff for the first time inside a function, by default, it will be locally scoped. What does that mean? It means that it will be referenceable. It can be referred to for its value like this, so long as the function is running. Once it's gone, once the function finishes, as in triggered by the return word, then the value, not the variable name, but the value will be returned back to the caller. That means in this case here, as we have also seen before in the sum profit in the earlier example. So the value will be returned back to the caller, but the scope will end. In other words, the diff container will be destroyed along with its value because we return a copy of the value back. So what about these parameter variables? They are also locally scoped. They are also going to be living only inside the function, so long as the function is running. So V1, V2 could have been replaced with X and Y, and because they are locally scoped, just like any X and Y are defined inside the function call, they are totally okay. They won't clash with any existing global variable. Okay, so if we run this, it is actually going to be just a pure revision because we have done that before. We basically just calculate the difference? So calculate V1 minus V2 minus X. Yeah. And then return the value. So minus V2 minus X. All right. And then return the value. And we call the function and then we print out. So totally okay. However, there's a subtle difference between this example and the previous example. And that is that when we never define a variable such as X inside here, right? Because it's a new scope, right? It's a new scope. So this variable X is being referenced prior to, in fact, throughout the whole function, it is not being defined at all. So do we get a name error here? Let's just run it. No, we don't. Why? Because any variable name inside a function, when you are running it and it is not being defined, is first searched in the global namespace. So when we need the value of X here, right, Python will look for, first of all, any definition of X in our function, which is none. So instead of giving a name error, it continues to go outside the bigger containing scope. So here we have global, and indeed we have a 4, 5, 6 here. So when we ask for the value of X, even though we didn't define the variable name X here, we can reference it. We can reference it. We can say, what is the value of X? When we actually meant the global variable X, right? So we can get the value 4, 5, 6, and we can get the, did we ask for Y here? Yeah, because we have calculated V1 and V2, right? So the value of F here is X and Y. Inside the function here, we get 4, 5, 6, which is possible because Python will automatically expand outward for the search of that variable container. called X. If it's not present in the local scope, it will go to outer scope. This is for accessing. Accessing. All right. Just quick reminder here, we are accessing before we define any value in the local variable X. And hence, the nature of X here is global. When we say X, we refer to the global variable. Okay, so without saying anything about X, without saying any special keyword telling Python that we are talking about the global variable, just by referencing X, just by it not being present in the local scope inside the function, we are automatically going to reference the global variable X. And so on, right? So the rest is returning the value. And the global variable X, of course, is not being affected. And so we get back another 4, 5, 6. This is for referencing before defining any variable X at all. And once we refer to it as X, meaning Python now concludes that X is the global variable X, then throughout the rest of the function, X has to behave like a global variable. Okay, so we can only read from X here. Now, what if we would like to tell Python that we're going to change it? We're going to change it, right? So over here, you see that X equals to X, so that's fine. Let's change it. Set global X to 1, 2, 3. All right, let's just do that. Because now Python knows that X is over here. X is referring to the global variable. That means if we want to change this global variable to 1, 2, 3, we should be able to, right? Let's run it and see. Nope, sorry. All right, sorry, you cannot. Because when you do that, you are actually trying to assign this 1, 2, 3 to a newly created local variable X, just like div here, right? Local variable X. But it clashes because currently, locally inside the function, any reference to X means the global container, the one outside there in the global space, right? But if you set it here, you are trying to create a new container that is also having the same given name, the same local name as this X. As this X and this X, correct? Because we are accessing it. And that is not allowed. That's not allowed. So we cannot do that. All right, and the other way around is this. If we change X to 1, 2, 3, all right, this is still not okay because when we do it this way, using what we have learned earlier on about namespace and scoping, we are creating a new variable called X locally inside the dynamically created namespace when we call difference function. So what happens is the container will contain 1, 2, 3, which is valid. And when we refer to this subsequently, it will have to be this local variable X, which will mask out, which will cover up, not deleting it, but it will cover up the global variable name called X, which contains 4, 5, 6. So when we print this time, we will see 1, 2, 3 instead, rather than 4, 5, 6 as seen earlier on, because we are now, any references to X is valid, first of all, because it's defined locally, but it refers to a different value, which we may or may not want. Right, so earlier on, we see that this was a nice thing because we don't have to worry that it will clash with a global variable name. But if we are writing in concert, that means we are writing in with the intended plan for it to interact between local variable and global variable, then we're in trouble because we cannot overwrite the value in the global space. We have been able to read, to access without saying anything, but we are unable to change the value in the global space. So that is up to here what we have discovered. Okay, so what if we would like to do that? What if we would like to tell Python, look, my variable X here is actually going to be global. All right, so the way to say it to Python is by using the keyword global. Okay, so here we are going to write a function called setX, which is supposed to set the variable, the global variable. Just want to check that we are positioning it correctly. set to 200. Okay. So what we want is to have a function that will actually set the global variable x to a value that we give. As we have seen, we cannot simply write x equals a new value because it will set x as the local variable. It will create a new local container called x, which will mask out the global variable, which means number one, we can't access the global variable x. Number two, we cannot definitely write cannot. Unless, right, at the start, we say that our x inside the function space, anytime we refer to x, we are talking about the global x. Okay, anytime we refer to x inside the function space, we are talking about the global x. So here, once we have defined this, we are telling Python declare that x is global. We can now set x to a new value. So if you make a function call, we are passing the new value as 200. So here, locally inside the function, new value will have the value 200. Then we are going to overwrite the global variables x from 456 to 200. So when we do that, the change is permanent because unlike earlier on when 456 was being calculated, now we change the global variable x to 200 and we calculate difference again. Difference is going to run the same logic, right? It's going to access the global variable x, but this time round it's not 456 but 200. So let's run it and see. And perhaps we can run it on a clean space. And then you see that here, that was the earlier run, F and G, but over here, it is actually H that we want, so that it's clear. So we have seen F, G, and H being printed, and inside the second run of the difference function, we actually see 200 rather than 456. So this is how we managed to change X. Now, without the global X, all right, the result will be very different because we are now just setting a local variable x and destroying it because we have reached the end of the function. So first of all, no error. But secondly, and more importantly, we fail to achieve what we wanted to do, which is to mutate the value of the global variable x. Right. So earlier on with the global x declaration, we can do it. Right. We could do it this way, but without, it's going to be a completely different function that is not doing what we want. Now, we can also run the word local, but it is to ensure that the variable is only used for local access purposes inside the function. But since by default that is always done, it's like anytime we have a newly assigned or newly created variable name like diff here, then it is automatically local diff. So because of that, seldom do we find Python programs using local because it'll be a lot of locals over in the function space that we write. Okay, so that's the difference between the keyword global and local. All right, so local is by default, so we don't use the word local, but it's there if you want. But global is definitely something very important and something very key in certain kinds of functions that we write when we want to mutate or change the value of the global variables.